Chapter 2, Section 2.6, Limits and Asymptotes. Page 85. We start with this introduction. Limit of the function k over x. When x approaches plus or minus undefined, the value will be 0. Example number 2. What is the limit of 5 plus 1 over x as x approaches undefined? The answer will be limit of 5 plus limit 1 over x when x approaches undefined. That is 5 plus 0, which is 0. The same for part B. Pi radical 3 is a constant numerical value, so we take it outside. The answer will be pi radical 3 times the limit of 1 over x times 1 over x when x approaches minus undefined. The value will be pi radical 3 times limit of 1 over x times limit 1 over x as x approaches minus undefined, which is pi radical 3 minus 0 times 0. That is pi over 3 multiplied by 0. So the answer will be 0. Page 86, we have the limit of constant divided by x power n, whatever power of n you have, providing n is a number greater than or equal to 1, the limit will be 0 again. Yeah, the limit of k over x squared, k over x cubed, and so on. When x approaches undefined, the value should be 0. Part A. Rational functions. Limit of a rational function 5x squared plus 8x minus 3 over 3x squared plus 2 when x approaches undefined. Here, when you have such a case, you should divide each term in the numerator and the denominator by the highest power of x, that is, we divide by x squared in this problem. So each term will be divided in numerator or denominator by x squared. And then you apply the limit. By doing so, you will get 5 over 3. Because any expression of the form k over x or k over x squared in the limit as x approaches undefined, you will have 0. B will be similar, as you see. Answer in this case will be 0. Now, a line y equal b is called horizontal asymptote when a limit of the function y approaches plus or minus undefined is equal to b. This b is called a horizontal asymptote. Yani in problem or example number 2, horizontal asymptote is 0. Is in part A is 5, but in part B is 0. In exercise or example number 3, the horizontal asymptote in part A is 5 over 3, and in part B, 0. Now I move to the second page. Page 87, exercise or example number 4. Find the horizontal asymptote of the graph of the function f of x squared minus or x cubed minus 2 over absolute x cubed plus 1. We calculate the limits as x approaches plus or minus undefined. When x is positive, absolute value of x will be x. And when x is negative, the absolute value of x will be minus x. So you will have these two limits considered for x positive and x negative. You will have in the first case the answer is 1. This is the horizontal asymptote when we have x approaches plus undefined, and when x is undefined from the positive side, and for x negative you will have another asymptote y equals minus 1. So we have two horizontal asymptotes according to the limits considered and because of the presence of the absolute value of x. Page 88, number 7. Find the limit of x minus radical x squared plus 16 when x approaching is undefined. the answer will be indeterminate of the form undefined minus undefined. Had the indeterminate form. What shall we do? As we did in the limits, calculation of limits involving radicals, we should multiply by the conjugate. Okay, and to get a new answer, the answer will be, as you see, following the steps, ending with a value 0. So 0 is the horizontal asymptote. Now, the third page, page 88, oblique asymptote. Find the oblique asymptote of function f of x equals x squared minus 3 over 2x minus 4. We do here division. Okay, the division, the classical division of a polynomial by polynomial. You will get the value as a quotient x over 2 plus 1, while the remainder will be 1 over 2x minus 4. So x over 2 plus 1 will be that oblique asymptote when x is approaching undefined values, because the remainder 1 over 2x minus 4 approaches 0. So we write the function g of x over 2 plus 1 اللي هو الquotient للdivision will be that oblique asymptote. Undefined limits. In the undefined limits, on page 89, we have the limit of a function f of x as x approaching a number from its right or left, and we get undefined value, as you see. Okay, then in this case, x equals a, we call it a vertical asymptote, يعني الفانكشن when it goes to the undefined value for a real number a, this a is a vertical asymptote. Example, 1 over limit of 1 over x minus 1. What's the limit of 1 over x minus 1? Upon substitution, the limit, I will get 1 over 0 plus, and 1 over 0 plus undefined. So, رحنا هلا 1 from the left. From the right, you will get minus undefined, يعني undefined in general. So I deduce that x equals 1 is a vertical asymptote. Last page. Page, as you see, this page is the last one in this PDF sent to you. Example 13. Find the horizontal and vertical asymptotes of the curve f of x equals x plus 3 over x plus 2. We start now studying the limit when x approaches undefined. You will get 1. So 1, y equal 1 is a horizontal asymptote. Next, we move to find the vertical asymptote by looking at the denominator x plus 2 and put it 0. So at x equals minus 2, we take the limit as x approaches minus 2 from left to from right. You will have undefined value. Okay, you will have an undefined value. Okay, so the number minus 2 is a vertical asymptote. Finally, example 14 will be similar. Find the horizontal and vertical asymptote of the curve minus 8 over x squared minus 4. As you see here, we consider the limit at plus or minus undefined value for the expression. You will get 0. So 0, y equals 0 is a horizontal asymptote. While at the solution of x squared minus 4, which is the denominator of the function, if I solve x squared minus 4 equal to 0, you will get plus x equals plus or minus 2. So we get now the limit when x approaches minus 2 of the function, and when the limit when x approaches a plus 2 for the function. In both cases, you will have undefined values. Therefore, x equals minus 2, x equals plus 2 are two vertical asymptotes for this function. Thank you.